everyone, welcome to our channel. Today we will be starting the second chapter of the LEED Green Associate exam. Let's begin with lecture 1 on the integrative process. Integrative process, which is a major concept of sustainable thinking, emphasizes the importance of connection and communication among all the professionals and stakeholders in the project. The analogy effectively illustrates the importance of integration and collaboration in project management. Just as each organ in the body must function properly and work in harmony with the other organs to ensure the overall health and functionality of the body, every member of the project team, whether project owners, stakeholders, or architects or engineers, must effectively communicate and collaborate. In an integrative process, the focus is on creating a cohesive system where information flows seamlessly between all the members throughout every phase of the project. This ensures that everyone is aligned, potential issues are identified early, and solutions are developed collaboratively. By fostering an environment of cooperation and open communication, the likelihood of a successful project outcome is significantly increased. Let's look onto the difference between integrated design process and conventional design process. So for the integrated design process, it is inclusive from the outset, which means that starting a process or a project by involving all the relevant parties and stakeholders right from the beginning. This approach ensures that everyone's perspective, needs, and expertise are considered early on, which lead to more comprehensive and effective outcomes. Whereas in conventional design process, it involves team members only when it is necessary. And other point is it's front-loaded, which means time and energy invested early on the project. Whereas in conventional, less time, energy, and collaboration existed in early stages. Then comes decision influenced by broad team members. For us, the conventional design process, more decision made by fewer people. Then for the integrated design process, it is an iterative process. Process refer to a methodology or approach where a process is repeated in a cycles, with each iteration building upon the previous one. It involves refining and improving a product or project through successive stages of development, feedback, and revision. This iterative approach allows for flexibility, continuous improvement, and adaptation to changes. So, for the conventional, it is a linear process, that is an open loop. And other points include all system thinking. So the whole system thinking refers to a holistic approach that considers the entire system or ecosystem rather than focusing on the individual parts or components in isolation. Whereas in conventional design process, the system often considered in isolation. And other points include integrated design process allows for full optimization, whereas conventional they limited to constraint optimization. Then seek synergies, whereas in conventional it diminished opportunity for synergies, and in integrated process it key prioritized to the life cycle costing, whereas in conventional emphasis only on the upfront cost. And finally, for the integrated design process, the process continues through post-occupancy also, whereas in conventional typically finished when the construction is complete. In late 2009, USGBC only stressed the benefits of integrative process delivery and did not awarded any credits for the project team. But under LEED version 4, integrative process delivery is available as a credit, and it was up to 1 point. And it is the only credit in this category. And in LEED healthcare project, this occurs as a prerequisite, not even a credit. Integrated project team is the critical factor to the success of the integrated design process. The project team encompasses key stakeholders and professionals from every discipline and requires the following. 1. Effective communication and coordination between the team members. Number 2. In-depth analysis to develop innovative solutions. Number 3, collaboration among all the members right from the early stage and throughout all project phases. And finally, decision based on information gathered from all the members to satisfy the project goal and prevent the conflicts. The example of the team members that may be included in the team are the architects or building designers, mechanical engineer, energy modeler, commissioning agent, community representatives, general contractor, green building consultant, lighting designer, facility manager, landscape architect, project manager, and many more. Now let's discuss on the integrative process credit. The intent is to support high performance, cost effective project outcomes through an early analysis of the interrelationship among the system. By coordinating early and often, USGBC encourage cost effective adoption of green design and construction strategies that follows owner's project requirement, abbreviated as OPR, and leverage the synergies among the LEED credits. So, owner's project requirement document is a written document used in all LEED projects that outlines the specific criteria and concept that the building owners determine to drive the success of the LEED project. There are three main phases for integrated process. They are discovery phase, then implementation and performance feedback. So the discovery phase is the preliminary stage where they perform the pre-designed goal setting workshop that is shared and use ANSI Consensus National Standard 2.0, which is the standard to be used, and basic water and energy analysis should be done, which we will discuss on the further slide. And on the second stage, understanding system interaction, which we found in the discovery phase, is utilized and document this state in the owner's project requirement and base of design, that is BOD. Then and on the final stage, here we will create a feedback mechanism that informs building operation and potential corrective action. So in conventional construction process, the projecting tasks are completed soon after the project completes, but in integrated process the duties or the responsibility won't be completed after the construction. It will be extended even after the operation and maintenance phase also. So for the first phase, in the discovery phase, there are two options for discovery. That is one, energy related system, and the other is water related system. For energy related system, the discovery is to perform a preliminary simple box energy modeling analysis before the completion of the schematic design that expresses how to reduce energy load in the building and accomplish related sustainability goal by questioning the default assumption, and assess at least two potential strategies associated with each of the following. They are: first is site condition. In site condition, we can assess the shading, exterior lighting, hardscape, landscaping, and adjacent site condition. Next is massing and orientation. Assess information like massing and orientation affect the HVAC system, sizing and energy consumption, lighting, and renewable energy opportunities. Then basic envelope attributes, which include the insulation values, window to wall ratios, glazing characteristics, shadings, and window operability. Then lighting levels, assess the interior surface reflectance values and lighting levels in occupied spaces. Assess the thermal comfort ranges, then plug and process loadness, which we need to assess the reducing plug and process load to the programmatic solution. And finally, programmatic and operational parameters, assess multifunctioning spaces, operating schedules, space allotment per person, teleworking, reduction of building area, and anticipated operation and maintenance. For the second stage, that is the implement phase, document how the above analysis informed design and building form decision in the project OPR and BOD, and the eventual design of the project, including the following: building and site program, building form and geometry, building envelope and facade treatment on different orientations, elimination or significant downsizing of building system, example HVAC, lighting controls, exterior material, interior finishes, and functional program element and other systems. For water-related system, the first phase is to perform a preliminary water budget analysis before the completion of the schematic design that explores how to reduce potable water loads in the building and accomplish related sustainability goals. Assess and estimate the project potential non-potable water supply sources and water demand volume, including the following. For this, we need to assess four water demands, which include indoor water demand, which include flow and flush fixture design case demand volumes. Then outdoor water demand include the landscape irrigation, and then process water demand, which include kitchen, laundry, cooling tower, and other equipment demand volumes. And finally, the supply source, which include the potential non-potable water supply sources volumes such as on-site rainwater and grey-water, municipal supply non-potable water, and HVAC equipment condensate. And for the implementation, document how the above analysis informed building and site design decisions in the project OPR and BOD. Demonstrate how at least one on-site non-potable water supply source was analyzed to reduce the burden on municipal supply or wastewater treatment system by contributing to at least two of the water demand components listed above. Demonstrate how the analysis informed the design of the project, including the following as applicable. One, plumbing system, then sewage conveyance and or on-site treatment system. Third, rainwater quantity and quality management system. Fourth, landscaping, irrigation and site elements. Fifth, roofing system and or building form and geometry. And finally, other systems. This is the end of today's lecture. Tomorrow we will start a new chapter. I hope everyone enjoyed this video. If you did, please support my channel by subscribing and liking the video. Thank you and take care.